Introduction of Modbus communication. This course will be divided in 4 parts. 1. Introduction of Modbus communication. 2. Modbus TCP. 3. Modbus RTU. And 4. Modbus slave address table. The lecture time will be around 20 minutes and there is 2 main goals. Familiar with the Modbus and the content of address table as a Modbus slave, and be able to use the Modbus debug tool. Let's start. 1. Introduction of Modbus communication. Modbus is a serial communication protocol developed for PLC application. Based on this protocol, the controller could communicate with each other or communicate with other devices via network such as Ethernet. The Modbus protocol is a master and slave communication technology. The device requesting data is called Modbus master, while the device which providing data is called Modbus slave. In a standard Modbus network, there is one master and 247 slaves allowed. Each slave will have a unique address. The master is also able to write data into slaves. Modbus is an open protocol, which is free of charge. Currently, Modbus has become a standard protocol of the industrial communication, and it is most common communication method between industrial devices. Usually, Modbus is used to transmit data or signals from instruments and control devices to the main controller or data collecting system, such as measuring temperature or humidity and send it to computers. Depends on the Modbus protocol version, it could support both serial communication, Modbus RTU and Modbus ASCII, and Ethernet communication for the Modbus TCP. Jaka Robot is compatible with Modbus RTU and Modbus TCP. How to use Modbus? In the Modbus serial communication, the simplest setup is that connecting the serial ports on those two devices, master and slave, with a serial communication cable. The data will be sent as 1 or 0, so called as bits. Each bit will send a volt as voltage. 0 stands for the positive voltage, 1 stands for negative voltage. The bits sending process is very fast. Typical speed baud rate is 9600 bits seconds. How is the data stored in Modbus? The data are stored in 4 different tables of the slave device. 2 of them are for coils and the other are 2 for registers. Both coils and registers include a readable table and read-write table. Each table includes 9,999 cells. Each coil is assigned as 1 bit in the address of 0000 to 270E, while each register is 1 word, 16 bits for 2 bytes, and assigned in the address of 000 to 270E. The number of the coil or register is considered as the position name. It will not shown in the actual data message, while data address will be applied. In the same network of Modbus, each slave will be assigned a unique address from 1 to 247. In the case where the master requests data from the slave, the first byte is a slave ID. In this way, each slave device will know if it should ignore this message or not after receiving the first byte. The second byte from the master is a function code. This byte will notify the slave which cells shall be accessed from the table, as well as read or write it. The most commonly used function code are listed in the table below. 01 is for reading single discrete output coil. 15 is for writing multiple discrete input coils. 02 is for read discrete input coil. 04 is for reading the analog input register. 03 is for reading single analog holding register. 06 is for writing single analog holding register, while 16 is for writing multiple analog holding registers. What is CRC? CRC stands for Cyclic Redundancy Check. It is for the error detection of each Modbus message. With adding 2 more bytes at the end of the message, all bytes in the message will be used to calculate CRC. The receiving device will calculate CRC and compare it with the CRC sent from the transmitting device. As long as any bit received is wrong, the CRC will be different and causing error. The difference between Modbus RTU and Modbus TCP is that a Modbus RTU is over 485 bus connection and Modbus TCP is over Ethernet cable connection. For the normal application, the Modbus TCP is recommended. Now, let's have a look at the detailed comparison between the Modbus RTU and TCP. Modbus RTU is over 485 bus connection. The Modbus RTU device uses RS485 serial communication protocol. It is suitable for the poor working condition when the real-time requirement is not so critical. Meanwhile, it has obvious cost advantages as it is using shielded twisted pair. As for the Modbus TCP, it's over an Ethernet cable connection and based on a TCP IP protocol. The communication data format follows the Modbus RTU data form. The Modbus TCP is connected with the slave devices via IP and port number. Slave address is not required. Modbus TCP is based on TCP IP with a high traffic rate, applicable for the high requirement real-time application. Modbus TCP. When the robot has the Modbus TCP slave, the external master sends a connection request to the robot. And then it will be allowed to control the Modbus I/O through robot after connection is established. In the APP setting, find the Modbus parameter setting in the hardware and communication. Select Modbus TCP, edit the port number and click confirm. The robot controller IP will be the IP for Modbus TCP, while the port number should be the same as assigned with the Modbus TCP master. After the connection is established with the Modbus TCP master, it will be able to read and write on the I/O in a corresponding address. The input address shall be based on the Modbus address table. In the I/O monitoring page, click Modbus tags. We could also check the related Modbus I/O. Now let's watch a video about the Modbus TCP setting. First is the controller DO. In the APP hardware and communication page, we could set up or view the Modbus TCP port. Open Modbus poll and then click Connection Method as Modbus TCP. And the key in the IP and port number of the robot. Click Connect and wait for the connection to be established. Click Setup, select function code as 02, input the address as 8, data length as 10, click Apply. Change the DO status from the app we could read the DO status from the software. Then for the controller DI, select function code as 15, starting address set as 40, length as 10, and again click apply. Through inputting the signal status from the software, we could read the DI status from the app. Then for the Modbus controller integer, click display. Select unsigned integer. Click setup. Select function code as 04 and starting address as 96 and data length as 10. Then you can finish and click apply. The AO status in the software. We could read the AO status from app. For the sign integer, click setup, select function as 04, starting address as 112, data length as 10 and click apply. Set the AO status in a software. We could read the robot AO status from the app. The sign integer can be negative and positive. Now, the Modbus float. Once again, click display, select 32 bits float big endian, click setup, select function code as 04, starting address as 128, data length as 10 and click apply. Set the IO status in a software. We could read the robot IO status from the app. The Modbus float integrates numbers after comma. Now the controller AI. For the integer, click display, select unsigned integer, click setup and select 16. Starting address 100 with input the register value. The status can be read from the app. For Modbus sign integer, click display and select sign integer. Click setup and select function code 16, starting address 116, length 10, click apply. Input the register value in the software, the status can be read from the app. Now the Modbus float, click display, select 32 bits float big endian, click setup and select 16, starting address 132 with input the register value. The status can be read from the app. the status data of the robot, click Setup, select function code 04, set starting address as 406, length as 10, click Apply. In the software, we could read the robot real-time position data. Now let's see the robot as a Modbus master. In case of the robot Modbus as TCP master, the dynamic I/O function can be activated in a Jaka Zoo app. The robot is able to control the slave I/O via sending a Modbus command after the robot is connected with the external Modbus TCP slave. Configuration: add dynamic I/O in an I/O monitoring page. We could input the dynamic I/O name, the IP address of the slave, and the port number of the Modbus slave. Then configure the I/O address and quantity of the slave. Note that in app, DI is input status, DO is coil status, AI is input register, and AO is holding register. Now let's have a look at the communication test video for the Modbus TCP master and the Modbus slave software. Open Modbus POL. Click connection method as a Modbus TCP. Set the port number as 502 and click OK. Then the Modbus slave is created. Then you can click Setup, select the address type 01, starting address as 0, length 10. Then click Create and set the function code 02, address as 0, quantity 10. Create another table with the function code 03. And finally, a fourth table with the function code 04. Open the I/O monitoring page. Click the Edit icon and add dynamic I/O. From here, we could set the dynamic I/O name. The slave can be any port number. Now, we set as 502. Same with the Modbus slave software. IP as the same as the Modbus slave IP. Configure the DI, DO, AI and IO starting address and length. All quantity as 8. In a case of no error as is occurred, means our Modbus master connection is established. We will need to check the coil status. In the software, we could edit the coil status. Then we could read its status from the app. As the coil is readable and writable, we could also edit the DO status from the app and monitor it from the software. Then for the discrete input statue, edit and discrete input value in the software. The statue can be read from the app. The statue is only readable. The same for the analog signal, the holding register. They are both readable and writable, so we could edit statue in the software and read it from the app. The opposite way will also do. The input register are only readable. Edit the input register value from the software. We could monitor its statue from the app. Modbus RTU. The controller can be the slave of PLC, controlled by the PLC. When the controller is used as a Modbus RTU slave, the external devices should use the RS-232, RS-485 convector with active photoelectric isolation to guarantee the stable signal and protect the IPC from the interference from outside. In the APP setting, find the Modbus RTU parameter setting from hardware and communication options. Select Modbus RTU. The slave address can be set in a range of 1 to 128, while the baud rate, data bit length, stop bit length and polarity method shall be the same as the master assigned. In the case of the robot as a Modbus RTU master, its dynamic I/O can be used. The robot is able to control the slave I/O via sending request after connection is established. To configure its parameters, add dynamic I/O in an I/O monitoring page. Edit the name and address of the Modbus slave. The baud rate, data bit length, stop bit length and polarity method should be the same as the master assigned. Then, set up the slave I/O address and quantity. After communication is established, the usage is the same as a Modbus TCP. Modbus slave address table. The first one is the controller I/O, which are the digital input of PLC. The starting address is from 8 to 128 in total. The second one, controller DI, which are digital inputs from the PLC. The starting address is from 40 and there is 128 in total. The third one, the controller AO, which are the analog input of PLC. Modbus Integra is starting from the address 96 and there is 16 in total. Modbus Sign is starting address 112, 16 in total, and the Modbus Float is starting address 128 and 32 in total. The fourth one, controller AI, which are the analog input of PLC. For the Modbus Integra, it's starting at address 100, 16 in total. Modbus Sign, it's starting at address 116 with 16 in total, and the Modbus Float starting at 132 with 32 in total. The fifth one, robot data, which are the analog input of PLC. The robot data include the statue of the robot joint enabled, error, position, current voltage, speed, TCP position and speed, tool and the coordinates. For the details, refer to the Modbus slave address table. That is all for this class. Thank you for watching.